Okay, chapter 8.2, arithmetic sequences. Sequence is a collection of numbers in a specific order. We can think of a sequence as a function, a sub n, where the domain n is a set of positive real integers representing the order term in the sequence. So in other words, this is the first term, second term, third term, fourth term. If we look at this as being our function, a sub n equals 2n plus 1, then we plug in each of the terms for n. So it would be 2 times 1, this would be 2 times 2 plus 1 equals 5. 2 times 3 plus 1 equals 7. 2 times 4 plus 1 equals 9. One of the things you'll notice, and we'll get to more later, but so this sequence here would be 3, 5, 7, 9, and it could keep going on and on and on, depending on how many terms we have. Clear down here to a sub n. You'll notice, and we'll talk more in a minute about this, but the difference between the two consecutive terms, is 2. So 7 minus 5 is 2, 9 minus 7 is 2. This 2, this number here, that represents our common difference. And if you go back and look at our original equation over here, you'll notice that 2. You'll also notice this equation looks like and mimics a linear function. And if this were a linear function or linear equation, that 2 would represent the slope. And that'll kind of come back a little bit later. So the other thing I just want to mention really quickly, the definition of summation notation. We will be going through this where this is a way to write the sum of the first n number of terms of a sequence. And it's represented by the Greek letter sigma. Okay, and I is the index of the summation, and this will be our, ultimately that'll be our equation, our function. And the upper limit is this n right here. That's going to be our upper limit, and that will usually have a value in it. That would be like, let's say that n was 4. So here, let's say this was 4. And down here we have I equals 1. That's our lower limit. So this is basically saying, give me the sum of the values, give me the sum of the first 4 terms. Okay, and there'll be some value in here, and then we'd find that. So this number here tells you how many terms you're going to go out. You're always starting with that 1, that lower summation. Okay. I mentioned briefly before about the fact that arithmetic sequence as a sequence that has a constant common difference between any two consecutive terms. So it's represented by D, that's the common difference, and it's any two consecutive terms. So it'd be A sub k minus A sub k minus 1. So go back to that example we looked at before. Okay, so A sub k, let's say that would be, this is the first term, second term, third term, fourth term, right? So A sub, let's say third term, minus 3 minus 1, which would be the second term. So the third term was 7, the second term was 5. 7 minus 5 is 2. So D equals 2. We saw that before. Okay. Let's take this into practice. Come down here. Let's look at 2 first. So we want to find the common difference. So we would take 2 consecutive, so 25 minus 21 equals 4. 29 minus 25 equals 4. 33 minus 29 equals 4. So we tested it. We don't just take 2 terms. We test it for few, but we see that we have a common difference, D equals 4. Okay. Let's come back here to number 1. So it says A sub n equals negative 7n plus 2. let's just make a quick chart. And here's n, our terms, and here's a sub n. So you have 1, 2, 3, and we'll just do 3 terms. Plug those values in there, so -7 times 1 plus 2, that would be -5. -7 times 2 plus 2, -14 plus 2 is -12. -7 times 3 plus 2, -21 plus, that's -19. And then we said that D equals, let's take the second term, -12 minus a -5. -12 plus 5 equals -7. And we can try that for some of the other terms here, and we wind up with the same thing. So D equals -7. Go back to our, oops, didn't mean to do that. 2, 3. Go back to our original equation, and you'll see that that lead coefficient, -7, is right there. That's our D. And I think I mentioned before, since this is a linear equation, and that D is also our slope of our linear equation. Okay, very quickly, and we're going to take a break. Let's leave that. Determine if the sequence is arithmetic. If so, state the common difference. So for this first one, we'll just go 5 minus 1 is 4. 9 minus 5 is 4. 13 minus 5 equals 4. So yes, since it has a common difference, since D equals 4, yes, it is arithmetic. All right, look at number 4. First of all, we know it's not arithmetic because this is not a linear equation. That is an exponential equation. But just to be safe, let's make our table. 1, 2, 3. 2 to the first is 2. 2 squared. 4 to the third power is 8. If we look at our difference, 4 minus 2 is 2, but 8 minus 4 is 4. So these values are not the same. We don't have a common difference. So the answer here is no. No, because 1, there's no common difference, and no, because it is not a linear equation. Come to the last one, 5 here. A sub n equals 3n plus 2. Number 1, it is a linear equation. So yes, it is. Yes, it's arithmetic. And then what is our common difference? Like we said before, that would be this value here. So D equals 3. And if you wanted to, you could always, if you're never sure or not quite sure, you can always plug it in and try the different, a few different terms. So 3 plus 2 is 5. 6 plus 2 is 8. 9 plus 2 is 11, and we see that indeed we have a common difference of 3. All right, that's it for now.